Good. So let's take a look at what our current trig function is going to look like. And again, we have two choices. We can either write y equals, so d is 46.5 plus 25.5 times the cosine of pi over 6 times x minus c. Or it could be y equals 46.5 plus 25.5 times the sine of pi over 6 times x minus c. Okay, now we got to choose whether we're going to use cosine or sine. And technically there is no wrong answer. I mean, they both can work out. However, I like to always work with cosine. And the biggest reason I like to work with cosine is it's easier to perform this horizontal shift back and forth. You see, cosine, if we look at this, cosine starts at its peak and goes down, whereas sine starts at the axis of oscillation. Well, if we look at this, we don't exactly know where this axis of oscillation is intersecting our equation, because we don't have an equation yet. However, we do know where our high value is, our peak value is. So what happens is, to get C, we're going to have to take whatever point we choose and shift it back to 0. That's how we get our shift. And if you try to do the sine, we have to figure out, well, where on earth is this? Whereas with the cosine, we know where the peak is. It's at 6. So we will use the cosine. So let's write that out. We have y equals 46.5 plus 25.5 times the cosine of pi over 6 times x minus c. And then we just have to figure out how far over this shift is. So if this was originally starting here and we shift over to 6, that means it is a horizontal translation of 6 units. So our horizontal translation . 6 units. In this case, c equals 6. And so our final equation is y equals 46.5 plus 25.5 times the cosine of pi over 6 times x minus 6. And there we go. So that trigonometric function models this behavior of normal monthly temperature. Now the next part is to find the normal temperature in December. Okay, now be careful here, because we started off with January at 0. That means we're going to put in 11. So y of 11 equals 46.5 plus 25.5 times the cosine of pi over 6 times 11 minus 6. And at this point, we definitely need our calculator. Okay, make sure you're in radians. That's always good. And so let's see here. We have the, I'm going to take 11 minus 6, which is just 5, times pi divided by 6, which gives us that 2.61799. Let's take the cosine of that answer, multiply that by 25.5, and add that to 46.5, and we end up with 24.4 degrees Fahrenheit. And so there is our, according to our model, there is the normal temperature in December.